Alright, welcome back from break. We're going to jump right into our next unit. Our next unit is SOL 6.17, which is sequencing. In this unit, you're going to learn about two specific kinds of sequences. One is arithmetic and one is geometric. And we're going to figure out the differences between those two sequences and things that are important about them. Before we can kind of move forward, we first have to know our basics about sequencing and what we have in a sequence. There's kind of a lot of vocabulary that goes with it, or a couple vocabulary words, but they're very important vocabulary words, and you're going to want to really memorize them and understand what they mean, or else this unit can be a little bit more difficult than it necessarily needs to be. You have a note sheet, and when I fill in words in a blank on the note sheet on the screen, then you should fill them in accordingly on the sheet that you have, because these are going to be glued into your notebook, and these are going to be the notes that you get on sequences. We're starting at the top where it says key vocabulary, and then the first one is a list of numbers or objects in a specific order. For example, 3, 9, 27, 81. This is simply an example of a sequence. So sequence is going to be your first vocabulary word for this unit. The next item on your list says it's a specific number or object in a sequence. So, for example, it would be the number 2 or the number 8. Not the entire sequence, but a specific one in there. And what that is called is a term. So if it says, oh, what are the next 3 terms in the sequence, or what would be the 8th term in the sequence, and wants to know what the next 3 numbers in the sequence, or patterns, or objects, or what the 8th term, or pattern, or object would be. Alright, moving on. So this gets into our kind of our specific things. You have 2 sequences that you're going to deal with, an arithmetic sequence and a geometric sequence. The first one that we're going to deal with is the arithmetic one, and an arithmetic sequence is a sequence that when you are, hold on. An arithmetic sequence is a sequence that goes from one term to the next by always adding the same value. If you are essentially subtracting, what you are actually doing is adding a negative value. The 2 operations we're going to look at in this unit is adding and multiplying. This is going to be part of the hardest things for you, is where you have to add the negative instead of subtracting, per se. A way that you can remember that arithmetic is adding is because arithmetic starts with an A and adding starts with an A. An example of an arithmetic sequence would be 2, 4, 6, 8. For this sequence, you are simply adding 2 in between each number. So 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8. So this is an arithmetic sequence where the rule is add 2. You could continue on, 8 plus 2 is 10, 10 plus 2 is 12, so on and so forth. In the same sense, another arithmetic sequence would be 8, 6, 4, and 2. You get from 8 to 6, you know, by subtracting 2. But what you are actually doing is adding negative 2, which just means that you're subtracting 2 except for in a different way. So 8 plus negative 2 would be 6. 6 plus negative 2 would be 4, and 4 plus negative 2 would be 2. Make sure you have both of these examples written down before you move on to the next part of the video. Alright, so I told you we were working with two different kinds of sequences, arithmetic and geometric. So this one is obviously going to be your geometric sequence because we just did the arithmetic one. So a geometric sequence is working with our other operation, which is going to be multiplying. So geometric sequence is a sequence that's going to go from one term to the next by always multiplying the same value. And just like we had something weird with the arithmetic one, adding a negative, this one is a little bit harder because it's got a little bit more going into it, but it's the same essential concept. So instead of dividing, you're multiplying by the reciprocal, which you should remember from our last unit is the multiplicative inverse. The reciprocal of, let's say, 4 is 1/4. So, for example, let's do an example of what a reciprocal is. Just so you can remember. So, if your number is 4, remember how you make 4 into a fraction without changing the value? Well, you make it 4 over 1. Therefore, the reciprocal, I'm just going to put REC for abbreviation, the reciprocal of 4 would be 1/4. So dividing by 4 is the same thing as multiplying by 1/4. Alright, let's look at an example of a geometric sequence. So an example of a geometric sequence would be like 2, 4, 8, 16, and 32. For this one, you should know that you get from 2 to 4 by multiplying by 2. Oops. And same, 4 to 8 by multiplying by 2. So 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. So the rule for this sequence would be multiply by 2. In the same sense, if you are given the sequence 32, 16, 8, 4, and 2, you get to 32, from 32 to 16, you know, by dividing by 2. However, you need to multiply by the reciprocal is going to be what the technical rule is. So, my original fraction would be 2 over 1, and if I multiply by the reciprocal, it would just be that flip, which would be 1/2. So, 32 times 1/2 is 16. 16 times 1/2 is 8. 8 times 1/2 is 4. 4 times 1/2 is 2. So for this, if you can figure out the number that you're dividing by each time, you just need to remember to put a 1 over it when you're identifying what the rule is, instead of saying that you're just dividing by that number. This is going to have a lot of practice so that you will get that into your head a little bit. Alright. Next, there are two other very important words and very important things that go with our arithmetic and a geometric sequence, and these are the technical names for the rules for each kind of sequence, and each one goes with a different one, and you have to keep them straight. You have to be able to identify what it is and what type of sequence that it goes with. So the first one that you have is something called a common ratio. And a common ratio is going to go with a geometric sequence, which is our multiplying sequence. A common ratio is the number or the rule that you multiply each term by in the geometric sequence. Again, remember the common ratio if you are dividing is that you multiply by the reciprocal of the number. So you have the common ratio, and then your other word is common difference. And this goes with our arithmetic sequence. And it should be kind of easier for you to remember because difference goes with the subtraction operation. And subtraction is the opposite of adding. So the common difference is the number or rule that you add to each term in an arithmetic sequence. So, and again, if you are subtracting, you're technically adding the negative number. So the common difference will be plus a negative number. Some things to highlight will be the common ratios and common difference are the rules. So sometimes you'll see the word common ratio, sometimes you'll see what is the rule that goes with a geometric or arithmetic sequence. And that's because I want you to be able to identify, well, does a common ratio or does a common difference go with the sequence they're asking for. So common ratios and common differences are just specific words that mean the rule that that sequence follows. And common ratios and common differences must be the same between each term. If you do one thing to your first number and something different to your next number, you don't have the correct ratio or the correct rule. You should be doing the same thing every time, which means if it only works for the first two numbers, you should try something different. Okay, let's do a couple practice ones. Number 1 says, look at the sequence, 12, 10, 8, and 6. First, you should identify, is this an arithmetic or geometric sequence? I know I can't divide by anything, or, well, first, I should be able to see that this is a decreasing pattern, which means I'm either dividing or subtracting in order to get my next terms. Which means I need to say, oh, can I divide 12 by something and get 10? No. Can I subtract 12 by something and get 10? 12 minus 2 would give me 10. You should make sure it works. If it works for the first three numbers, it probably goes for the whole sequence. 12 minus 2 is 10. 10 minus 2 is 8. And 8 minus 2 is 6. So I would say that seems pretty good. I'm subtracting, which makes it an arithmetic sequence. And then step B says, find the next three terms in this sequence. Well, 6 minus 2 is 4. 4 minus 2 is 2. And 2 minus 2 is 0. The common ratio or the common difference is what? Well, I'm going to have a common difference because it's an arithmetic sequence. And that's what difference goes with. And what did I do each time? Well, I subtracted 2, which means I added negative to each time that I went from a different number. Okay, number 2 says, look at the sequence, 64, 16, 4, 1, 1 4. Again, this one is also decreasing, which means I'm either going to be subtracting or dividing. Because there is such a large difference between 64 and 16, it's pretty safe for me to assume that this is going to be a division one. So I need to think, oh, okay, how can I get from 64 to 16? Well, I can divide by 4. And maybe I don't know 64 divided by 4 is 16, but I know that 16 divided by 4 is 4, and 4 divided by 4 is 1. I know those things. So I'm dividing for this one, which would make it a geometric sequence, which would then therefore mean that I had a common ratio instead of a common difference. And I'm dividing. However, my common ratio can't be divided by 4. It needs to be multiplied by the reciprocal. The reciprocal of 4 is 1/4. So each time I'm multiplying by 1/4. If you miss anything or are unclear, want to go back and rewatch some of the video, please feel free to go ahead and do that. Make sure your notes are all filled in. Make sure they get glued into your notebook. And we're gonna do some practice.